Okay guys, in this video what we're going to do is talk about the classification of matter and kind of break it down into a big tree to kind of show us that how we break down matter and where does it kind of fit in our world. So we're going to start off with this idea of pure substances. Okay, so when we talk about matter and we go to our board here, we're going to start with the term matter. And we're going to have pure substances as one of our big categories. Okay, it's one of our two big overarching kind of classifications of that. Underneath pure substances, we have two types of pure substances. We have elements and we have compounds / molecules. Okay, so our pure substances, we have elements and compounds or molecules. Okay. So those are our two kind of biggest categories here. So let's talk about a little bit of each one of those two different things. Okay, so the first one, elements. Okay, elements are our building block of nature. Okay, so there's about 118 different elements on the periodic table. You can find them there, and they're basically what everything is made up of in terms of matter in our universe. Okay, now if you have a single entity of an element, okay, or a single particle that gives you the representation of that element, we call that an atom. Okay, so if you have oxygen or iron or copper or carbon, whatever it is, if you have one iron, you have an atom of iron. Okay, it's still iron, it's still the element iron, it's just a single atom of that. Okay, so under elements, we tend to have atoms. Now, we also can use the term molecules here, because some of our elements don't come as individual atoms. So things like iron do, and copper does, and carbon, and like helium, those are individual atoms. Okay, but we also have things that come in groups or pairs. So when you have a single element that comes paired up, we call that a molecule. So that's kind of like oxygen, which is O2, or nitrogen, which is N2, or hydrogen, which is H2. These are just elements, but they don't come as individual atoms. They actually come as molecules or bonded together atoms. Okay, they come in sets of two, that kind of stuff. So we call them molecules. We also can use the term molecules over here with compounds. Okay, so when we're working with this idea of compounds, compounds is anytime you take two elements, or I guess you take two elements or a single element. Doesn't really matter. You take any two atoms and bind them together chemically. Okay, giving us a chemical bond like we talked about previously. All right, so we call that a chemical combination. Now, this does something for us that's kind of unique, that's sometimes hard for people to kind of grasp onto. It actually creates what we consider a brand new pure substance. Okay, so when you start to move and create chemical bonds, you're actually changing the chemical nature of that substance. Okay, so when you have a compound, let's say we have something like, sodium. Sodium is abbreviated Na. And we have something like chlorine, which is Cl2. So we have an atom of chlorine, we have an atom of sodium, we have a molecule of chlorine. If we combine them chemically, we can make salt. Sodium chloride, or table salt. Okay. Now, here's how chemically different these two things are than this. All right, so if we take a look, sodium in its pure form, if we were to put this in water, it explodes. Okay, so basically if you were trying to eat this, you die. Chlorine, okay, is one of the precursors to mustard gas. Okay, chlorine is toxic to people, so if you breathe in chlorine, you die. Okay, so this means death, this means death, this means delicious on French fries. Okay, big difference here. All right, so sodium chloride, we have now created a new compound. It is a pure substance all by itself. So this is a pure substance, this is a pure substance. Even though we have two different elements here, we create one pure substance called sodium chloride, or the compound sodium chloride. Okay? The key here is that they're held together by those chemical bonds. Okay? So all of this in here are held by chemical bonds on this. All right? So that is kind of our first side of this category system. Okay? If we take a look at the next side of this, so if you're not a pure substance, if you're not an element or a compound molecule, The other option that you have is to be a mixture. Okay? So if you are a mixture, now we're physically putting things together. Okay? We can have macroscopic mixtures, like a nice lettuce salad, or a delicious like combination pizza. Okay? Those are kind of macroscopic mixtures. Grains of sand are a mixture. Okay? Vinegar, Italian dressing, that kind of stuff are all mixtures, those kind of things. Kool-Aid, coffee, milk, all mixtures, okay? So we're physically mixing things together. Now, when we talk about being a mixture versus a compound, okay, the key here is that the substances retain their individual properties. So if you have a mixture of, let's say, sand, you have your different pieces of sand, they all have their own properties to them, okay? So you don't create a new compound or a new substance from that, you know? If you have a mixture of salad, the tomato in there doesn't bond to the peppers and bond to the, you know, cheese or whatever else you put in your salad. They maintain their own individual properties to them, okay? Now the key here with mixtures is all mixtures are only held together by IMF. Okay, so they're not held together by chemical bonds. They're held together by intermolecular forces, or that physical world we talked about before. All right? Now, there are two types of mixtures. We have homogeneous mixtures. And we have heterogeneous mixtures. Okay? So we have a prefix homo and a prefix hetero here. And obviously we know that those prefixes are, okay? So homo meaning the same, hetero meaning opposite or different, okay? So when we talk about these two different mixtures, if we have a homogeneous mixture, it is something that is evenly distributed, so it looks the same throughout, okay? Solutions. So think of anything that comes in solution form. Pop, Kool-Aid, milk, coffee, any of those kind of things that it looks like it's all the same together, that you basically, if you look at it, it looks like one thing, but you know there's more than one thing in there. Those are solutions. Those are homogeneous mixtures. Okay? Alloys. This is one that a lot of people get wrong, or there's a misconception here. Alloys are when you take two metals, one metal, two metals, put them together physically. You don't chemically bond them. Okay? So when we make brass from copper and zinc, or we make bronze from copper and tin, we're not actually chemically bonding the brass or the copper and the zinc together. We're just physically mixing them. We're taking liquid copper, liquid zinc, pouring them together, stirring it up, we get brass. So the physical combination of the two gives us some different physical properties, but not chemical properties. Okay? So we still have just a mixture there in terms of those things. So solutions and alloys are the two things that most students get wrong when it comes to homogeneous mixtures. They don't realize that solutions don't actually cause a chemical change there. It's just a physical change. And then our heterogeneous mixtures are anytime we have uneven distributions. Okay? So if you can look at it and you can pick out the differences and different parts or different sides to it, it's heterogeneous. If you look at it and if you didn't know any better, you think it was one thing. Okay? Think of like milk. Okay? When you look at milk, if you didn't know any better, you might think that that white stuff is just one compound. But you know there's water in there, there's dairy products in there, there's, you know, vitamins A and D and that kind of stuff all inside there. So you know that it's actually a mixture that's homogeneous in nature. Okay? So if we take a look at some of these microscopic views, I'm actually going to back out because I didn't show you this under the pure substance side. So here, if you're microscopically looking, these are maybe a way of looking at elements. Just single spheres kind of deal. That's an element. This is a molecule of an element. Okay, so here's a molecule of an element because it's two of the same color. Here we have a compound where you have oxygen bound to two hydrogens to make water. So this would be the water compound. This would be maybe something like chlorine gas or oxygen gas, something like that. And here you have just individual elements. So here's an element. This would be like a molecule, and then this would be a compound. Okay. This could also be considered a molecule down here too. These are both molecules, but this molecule is not a compound. Okay. Kind of separate those two things out. Okay. Over here we have a mixture of two elements. So we have this element and this element, but they're not chemically bound together. Notice how they're not attached. Here we have a mixture of two different molecules. So we have our little red molecules and we have our purple molecules, and they're mixed together. Here we have a mixture of a molecule with a compound. Down here we have a molecule with an element. Okay, so there's lots of ways you can create mixtures. Okay, at the microscopic level and at the macroscopic level. Okay, if we take a look at those two different things. Now if we jump out and move over to this website, here's just another place you can talk about microscopic views. You can see them. They do a good job here of basically talking about elements, compounds, and mixtures and what they are and how they're different from each other. So just another place for us to go to if you want to. We'll link this to our website also for you guys as we are working. Okay, so let's go down through here. All right, so that ends that video there. We'll talk about conservation of mass in our last video. Thank you.